All right, family. So good day once again. I believe today too we are all doing great. Very good. So I will welcome you once again to Sir Ben's online channel. And today too we are here to expose you to what we call algebra. That is the branch of mathematics where numbers and variables come into play. Today too we are diving into what we call factorization. And as you can see what I have on the board here, I have what we meant by factorization in terms of what? Algebraic expressions. So under factorization, what we normally do is we are just going to factorize the common terms out, then the uncommon terms will remain in a bracket. So under factorization, we have types of factorization. So the first type of factorization is called type 1. I have termed it as well type 1. So with the type 1 factorization approach. This one goes with expressions in an algebra that contains how many terms? Two terms. So anytime that we encounter problems with expressions containing two terms in mathematics, where we are asked to factorize, have it in mind that the idea in terms of factorization that you are going to use is called the type 1 method of factorization. So as we can see, there are some questions on the board that I want us to go through it one after the other so that at the end of the day, you will be blessed. So I said with a type 1 method of factorization, it involves or we mostly employ it in expressions which contain only two terms. So here, as you can see, I have question number one. We are going to factorize it. So question number one, it says 3ax plus 6ay. This is one term, this is another term. So precisely they are holding how many terms? Two terms. All right, so we are going to look at how to factorize in the same manner we will look at how to factorize this and throughout. Remember, I told you that this is type 1 factorization, and this method of factorization or this process involves only two terms. We can only apply this method that we are going to use in factorizing this only when the expression involves what? Two terms. All right, so please come closer, stay tuned, and make sure you watch this video to the fullest so that you enjoy the benefits that we are giving it to you today. All right, so let's see what math has for us today. Factorization. So we are going to start doing that. All right, so as you can see, question number one, it says we are to factorize 3ax plus 6ay. So having this, going to factorize this, what normally comes into mind under factorization is we are to identify what you call like terms. And most of the times, students find it confusing when they are factorizing any expression, especially when they are asked to identify the common terms among these two terms within the expression. So we are going to find the common term over there. Okay. Now, as you can see, we have 3 here and there's a here too. So you can see that the 3 can be found within the 6. I get it. So I want us to look at something here. How do we identify the common term among these two, listen, or the common term among these two expressions? How do we do that? What I am going to do is I'm going to take the terms one after the other and partition it. I'm going to partition it. All right. Now, let's see what is going to happen here. We all know that in mathematics, this 3ax can be rewritten as 3 in a bracket, a in a bracket, then x in a bracket. Now plus, when I come here, remember I can rewrite this as 6 in a bracket, a in a bracket, then y in another bracket. Okay, so I will continue writing this. Now, the numbers that I have there, I have to break the number down so I get what? Prime numbers. Now, this is a prime number. The a here has a power of 1, so I will leave it like that. The x here too has a power of 1. I will leave it like that. But when I get to this side, the 6 is not a prime number. So I have to decompose the 6 to get prime numbers. So let's come here. This I'm getting 3 in a bracket. I'm getting a here. I'm getting x there. Plus, you see 6 For me to decompose 6 to get prime numbers, I'm going to get 2 and what, 3. So I can rewrite this 6 as 2 multiplying 3, and 2 times 3 will give me what, 6. So a, then what, y. Are you with me here? Very good. So here the a is power 1, here y is squared. Sorry, y has a power of what, 1. So this one, so I will leave it like that. Now, so when we come here, we can easily identify the common terms out there. So you can see that I have 3 here. So 3 comes out. I have a here, I have a there. So a2 comes out. Do we have any common member? There's x here, but we don't have any x there. There is 2 here, we don't have any 2 here. There's y here, we don't have y there. So it means that we are done identifying the common terms. So if we are done like that, then I can easily open my bracket and come to this side. I'll write what I have left. Okay, I'll write what I have left here. Now remember when I was cancelling, here cancels, leaving 1 1 over there. Here 2 cancels, leaving 1 1 over there. So what I'm going to do is I'm going to just multiply this. Here is left with 1. Here is left with 1. So I'm just going to multiply the 1 times 1 times x. I'm going to get what? X or 1x. Okay, so plus, when I come to this side also, I have 2 left. Here is left with 1, here is left with 1, here is left with y. So I'll just multiply. So look at it, the plus is there. So 2 times 1 is 2, times 1 is 2, times y is what? 2y. So here becomes what? 2y. Then after, I will close my bracket. So that means I am done factorizing the expression 3ax plus 6ay. So this is how to go about it. Now, students find it challenging when they are asked to find the common term that is among these two terms. And please, if you find it challenging doing that, kindly use this approach and it will help you. So this is how to go about it in such manner. So question number 1, my answer now becomes 3a. Let me write it well so that you can see. So 3a in a bracket x plus 2y. That becomes my answer for question number 1. Very good. So quickly, let's dive into question number 2. I believe you understand the process. So if you did not get it, we are going through question number 2 also. So please stay tuned. Then we all move on with life. Question number 2. I have x cubed minus x squared y. All right, so that is the expression that I have here. Now we are going to factorize this expression, x cubed minus x squared what, y. So for me to be able to factorize this, in the first place, I have to get what we call the common term or the common member. When we say common member, we are referring to a term or a member that can be found within the first term and the second term. So in doing that, I am going to use a simple approach that I use for the question number 1, okay, to help you understand it. So I'm going to break this number down or this variable down so that I will get so that the power of the x cube becomes what? 1. Okay. Now remember when we have x squared, x squared can be written as x in a bracket then x. In the same manner, when we have x cubed, this is the same as x multiplying another x. Okay. So when we multiply all these things, remember the power here is 1, the power here is 1. So I'm just going to add the powers. So here becomes 1 plus 1 plus another 1. So this becomes s cubed. So this is the same as what I have there. So in the same manner, so when we come here, we mean here becomes x multiplying another x multiplying another x. And when we multiply this 3x over here, we are going to get x cubed. So as you can see here, I believe you are following very good. So I'll just move on with life. Then my minus here. In the same manner, when we come to x squared, this can be written as x in a bracket x multiplying the y that I have over there. So after, I mean, getting something like this, remember we said that the power of the x should be what? 1. Assuming here the y here is power 2, we should have added another y to it. Assuming here the power y is here, so we should have added another y to it. Are you getting me? So we are going to disintegrate, or we are going to break the variables down so that the power does not remain as it is, but rather it tends to be what? 1. All right. So by here in the question, the power of y was power 1. That is why we left it as this. Now our next step is to identify the common terms. So I'm just going to identify the common term. Here I have x there, leaving 1. Here too, I have another x there. Here I have another x there. Here too, leaving another x there. Please, I believe you are following. There is left with another x here. There is one x here. Another x is left here. Now, let's ask ourselves, do you have any x left? No. We have y here. Do we have any y left? No. So, our common term, we first of all indicated this. So, this one comes out, okay, in a bracket. Then we also indicated this, so that one too comes out. Then I will write down what I have left here. So when I come here, here is left with x minus, and here too is left with what? Y. So I'll put that one in the bracket. Then after when I come here, I'll just multiply. So I'll just multiply x by x, where I'm going to get x squared in a bracket, x minus y. Or I can rewrite this one again as x squared bracket open x minus y. I believe you get the concept. Thank you very much. So our answer for question number 2, we are getting x squared in a bracket x minus y. So that's what we are getting for question number 2. Now quickly we dive into question number 3 also. So with question number 3, I have 54 minus 81x. All right. So this one also, as we said, we are going to identify what we call common what term, common term, that a number that can be used to divide this and this one evenly without a remainder, okay, or a member that can be found here and found here at the same time. So in doing that, we are going to break down the 54 to get prime numbers throughout. Now breaking down the 54, we are going to getting some prime numbers over there. Two numbers that when you multiply get 54. I can have 6 and then 9. But as I said, is 6 a prime number? No. So I'll take another number, which is 2 and 3. Here gives me 3, 3. I believe you are following. Very good. So here, it means that the 54, I can rewrite the 54 as 2 multiplying 3, multiplying 3, multiplying another 3. Okay, so the 3 is how many? 1, 2, 3. So remember, we said we are breaking down the 54 so that we get prime numbers throughout. Remember, when we multiply all these things, yes, we are going to get what we have up there. So we are just identifying the prime numbers that are found within what I have over there. I believe you are following. Very good. So let's continue with life. Now minus, let's come to the 81 also. So the 81 also, I am going to identify all the prime numbers over there within the 81. So with the 81, I can have 9 and then 9. 9 is not a prime number, so I will decompose it. And I'll get 3, 3. Here too, I'll get 3, 3. So over here, when I come here, I have 3 by 3. Remember, the 3 is how many? 1, 2, 3, 4. So another 3 comes, then the last 3 comes. So that's what I am getting for the 81. Okay. Then it's left with the x attached to it. So the x2 will come there. So let's identify the common terms. There's 2 here, there's no 2 there. I have 3, I have 3 there. So the 3 goes away. We're coming here with the 3. Remember, we said we are identifying the common terms. So when we come again, we have 3 here, we have another 3 there. So another 3 to come and multiply. We have 1 and 1 3 here, another 3 there. So another 3 will come and multiply. I have another 3 left here. We don't have any other 3 left behind. X is here, we don't have any x. 2 is here, we don't have any. So I'll open my big bracket and I'll write the uncommon things. So when I come here, what number is left? It's left with 2 over there. So I have 2 times 1, which is 2, 2 times 1, which is 2, times 1, which is 2. So I have 2 left there, minus I have, yes, left with 1. So 1 times 1, which is 1 times 1, which is 1 times 3, which is 3 times x, which is 3x. So that's what I'm getting. Then after, let me rewrite my answer. Well, I'll just multiply all what I have here. 3 times 3 is what? 9 times 3 is what? 27. So I am getting 27 in a big bracket, 2 minus 3x. Are you following? Let me rewrite the answer. So I'm getting 27 in a bracket, 2 minus 3x. So this is what I am getting for factorization. So question number 3, our answer for question number 3, we are getting 27 in a bracket, 2 minus 3x. So that's what we are getting for question number 3. I believe you are following and you are getting the concept. Very good. So now we dive into question number 4.